Hi everybody, this is your instructor for the online C++2 class. I'm making this video for week 12 and 13, similar to how I have done for the previous week. So when I have made this video, you will see this link similar to the chapter 11 video lecture and assignment help link under week 12 and 13 as well. The textbook chapter that we'll be going over this week is the chapter 12, pointers, classes, virtual functions, and abstract classes. This is a quite important chapter because if you're conversing with somebody about C++, more or less your conversation will point towards the pointers. We'll also learn about classes, virtual functions, and abstract classes. So let's get going with this chapter. Um, Pointers is slightly different than what we have learned in our previous chapters, where we learn about the simple data type and structured data types such as structs and enums and classes. But pointers is a different type of data type where pointers does not really contains any data. It contains pointer to a memory location. Pointer variable is a variable whose content is an address, that is a memory address, and is therefore set to point to a memory address. So as I said before, it doesn't contain any data, it just has a link to another memory address. How do you declare pointers? You use the asterisk sign in front of the data type, in front of the identifier, the name of the pointer with the data type preceding in the beginning. For example, here we have int asterisk p, which is a pointer of type integer, and character star ch, which is a pointer to a memory location that can store a character. You can use the asterisk in at the end of the data type or in the middle, it doesn't really matter. When you're declaring multiple variables, you must use the asterisks for each one individually. So in this example here, you will only have p as your pointer and not q. You will have to explicitly use the star sign, asterisk signs in order to declare two pointers. Uh, uh, the address of operator and ampersand is basically it gives you the address. So if we have an integer x, the x can have 15, but where is it stored in the memory? That's the address. And if you need to grab that address in order to put it into a pointer such as the star p, then we'll use ampersand x. What it would do is it will take the address of x and put it into p, so that p will point to the same memory address where x is stored in the memory. So here is another example. We have number one, number two, and number pointer. Number one is 100. Number two is also equal to number one, and number pointer is pointing to the memory address of number one. So the number one is 100, but where is it stored is now present in the number pointer. So if we spit out the number one, we'll get 100. If we spit out the number pointer, we might get something as the memory address and not really the value. Dereferencing operator, which is the star sign we have used, so it's also called indirection operator. So here, if we have x is 25 and if we have a pointer of type integer by the name p, we can take the address of the x by using ampersand x, and if we were to display the output as star p, we will see 25. If we use the star p as 55, we are practically changing the value in x. So here is another example on the same concept. We have a pointer p and a number. If they are stored in two different locations in their memory, but what goes in this p, which is designated in the orange color, is the address. So it will store 1800 and not any value per se. It will going to store the address. If the number is 78, 78 will go into the number. And if we are putting the pointer p with the address of the number, then it will store 1800. So basically just a linker to the same memory address. And if we put star p equal to 24, we are actually modifying the value in that address 1800. So this is how you have the pointers being used in C++, which is explicit, which is mentioned here as well in what I just told you. Similarly here, we have pointer p and x, two different locations. The value of ampersand p, p star p, ampersand x, and x are as follows. In the beginning, we have ampersand p, which is the address of the pointer. we have ampersand x, which is the address of the x. The x is unknown, the p is unknown, and star p does not exist because we haven't even given any memory address to the pointer yet. If we put x equal to 50, then x will be 50 and rest all will be like this. If we do p equal to ampersand x, then we will have these lines execute. And if we do p equal to ampersand x, we are populating the x, the address of x into our pointer. So it will point to the address, which is 1750. And ampersand p is still the address of the pointer, and star p will return the same value that is stored in x. If we do pointer p equal to 38, we are practically changing the value of the in the memory which is stored in the pointer. So we are basically going to modify the value of x by using this last line as you see here. So these are very practical and important points that you shall look at. Here is an example of how it is used, where we have a radius and a radius pointer. We grab the address of radius, put it into the pointer, and we are just utilizing the ampersand radius pointer to display the same output that we would get if we are using the radius, which is just a normal double variable. So we'll get the same output if we do this, or we'll get the same output if we do this. So we are using the parenthesis because the star sign, which is also used for multiplication, is not to be confused with the star sign in front of the pointer variable name to get the value in the memory address that is stored in the pointer. And if we do this, here is the output which will come. Sometime when you are displaying the address of the memory, when you're running, the address on your computer may be different than the address that are shown on line 19, 20, and 21 in this textbook example. But these are like 10, 15, 24 lines that you can write by yourself and learn about it. We learn about classes and struts, and now let's bring up the pointer variable as well. So if we have a strut where we are combining different data types to make a structure, we can use a pointer as well for struts, and it will point to the same memory address where the strut is located. If we were to apply some calculations or fill up one of the elements of the strut, we can absolutely use the same concept we just learned in the previous page. We can use star and the student pointer dot gpa equal to 3.9. We must use the parenthesis because it's very important to not confuse the star sign, which is also for multiplication. Um, so kindly keep that in mind. In order to avoid this usage of parentheses and the star sign, the C++ does allow us to use a combination of two characters, which is the a dash and an arrow. By using this, we can use a pointer variable and directly access the class members inside that. So instead of writing like this, you can also write like this. Something to remember as well. Here is an example on the concept of class struts, which is where we have a void set x and print, and we have the definitions of the two. If you're using a class example, we can create a pointer and create an object, store the value or the address of the object inside our pointer, and use the dash and arrow to set the values. By doing this, we are basically doing exactly what is shown in this picture here. As we learn, this is what's happening. Initializing pointers. Pointers are given no values. We can also use specifically null or zero, so that it has no address stored in it. We can also use a special character, a special reserve word, which is nullptr. As you can see here, this is a special which would make it point to nothing in programming world. So it will be stored, it will have no reference as such. And if we use that, then we will ensure that our program doesn't behave randomly. We can also, we learn about variables in the previous chapters. The variables that are created during program execution are called dynamic variable. Your assignment for this chapter basically is about dynamic variables in a way. We have two words, which is new and delete. These are reserve words. They allow us to create instance of variable during program execution. So if we have consider like integer p pointer, character q pointer, and x, the statement p equal to ampersand x will store the address of this x, which is an integer variable, into the p pointer, which is also an integer variable. We can also do p equal to new int, which will basically create a new integer on the fly and store the reference of that address in the pointer. So without creating a variable explicitly, we can just without writing something like int x explicitly, we can just say, hey, this pointer is going to store a new integer and the address is brought forward into the pointer. So without declaring explicit variable, we can create dynamic variables just like this, where we are saying the pointer q, which is a character, will be pointer to a character array of 16 places. So we can do just like this as you saw in here. The delete basically, let's see, we have a p equal to new pointer and star p equal to 54. So we are just storing 54 into that address. And if p equal to new int and star p equal to 73, this is what's happening. We have uh, we created a new memory address. We stored 54 in it by using these two lines, and then we create another memory address and stored 73. What happened to the previous one? Well, we basically lost it. It is a memory leak. We have no reference to that because it's gone. It's there, but it has filled up with something, and we just created a memory leak. So how do we prevent that? We prevent that by using the delete operator. So by doing delete pointer variable name, we deallocate the memory address and the memory which is stored into our pointer. So you shall use something like this to delete a dynamic variable you have created, so that you don't have a pointer which is dangling, or a memory address which is leaked. The same thing is kind of demonstrated in exercise 12-5 in these pages, where we have a radius pointer. Similar to what we did, we create a new double variable to store a new memory address we just spawned off into this radius pointer. Then we are asking for values. We calculate, we display the address, and then we delete it so that we don't have a dangling pointer and a memory leak. After doing that, if we were to use it, we need to create a new double for the pointer and do the calculations again. So that this is a good way to make sure we do not have any um, memory leak happening in our application. Kindly read through this. These are simple examples that can help you. What are the operations on pointer variables that we can do? Operations that are allowed on pointer variables are assignment and relational operator, and some limited arithmetic operations. So we can do some basic operations such as the assignment, the relational, and some limited. So if you have two pointers p and q, they are having two different memory addresses. If we do p equal to q, it'll copy the value of p into the q. That means they'll both point to the same memory location as mentioned here. The two variables, if they are two, can be compared for equality. So we can compare using double equal to sign. We can compare as not equal to sign. Depending on the memory addresses, it will result into true or false. Here we have four pointers, and if we do p plus plus, the p equal to p plus 1, we are actually pointing the pointer to the next memory location. So since p is an integer, it'll become 4 bytes higher than whatever address was it in the beginning. Q is double, so it will move by 8 by using q plus plus, and character pointer will move by 1. A student pointer increments the value of student pointer by 40 bytes. A student pointer is something that was defined in the past, and it was a collection of different data types. I think it was probably a struct, and therefore, depending on how much data type is consumed by the individual elements of the strut, the increment operator plus plus will increment it by that many number of bytes in your memory. Um, if we do plus 2, it will increment by 8. So these are kind of difficult. So you don't expect, like, if I have a value 2 and if I do p equal to p plus 2, it will become 4. It will not become 4. It will become totally different because it'll move by 8 bytes. Dynamic array is what you have to really pay attention, because this is covered in this assignment for chapter number 12. So we when we create an array during the program execution, we call it dynamic array. Rather than creating explicitly, we create it on the fly. So if we have a integer array, integer pointer, and we can create a new array of 10 integers and point p to the first element in that 10 contiguous memory location. So p pointer will have the address of the first element, and then we can do p plus plus to get to the second, p equal to p plus 3 to the next one, and so on. So this is a good way of navigating in an array by using pointers, as you learn by what we learned in the operator, the plus plus operator, and what we are doing here as in a dynamic array. This is exactly what I mentioned. P25, the first element will be 25. If you do P++ and set it to 35, the first element will be 25, second will be 35. And by doing so, we can store, by using a for loop, we can set all the values to 0 depending on the size of the array that we have. And this is exactly what I was telling you about in the beginning, whereby the list will point to the first memory address, and by using the suffix, we can navigate to the individual elements in a dynamic array. Here is an example where we have an integer a pointer and an array size. We ask the user for the array size and declare an array of that size and put the pointer of the first memory address into our pointer. This is exactly what you will be coding for this week's assignment. Let's zoom in a little bit so that you can see it much better. Array and range-based for loop. So there is a little catch with using the range-based for loop. So if we have a for loop, which is the usual typical for loop in C++ as well as Java, we can absolutely use array pointer and navigate. But if we are using a for loop, which we have learned for navigating in an array, you cannot do that. It's illegal, because the list will not give, if list is an array, but it is a pointer, it will not give the position of the first address into the X, and therefore it will not function properly. So the range-based for loop is illegal and will result in syntax or compilation error. We can use the range-based for loop on a normal array, but a range-based for loop cannot be used on a dynamic array. So if we are writing a code something like this, where we have an int main and we are using a pointer, and if you're trying to use this for auto x, we will get a compilation error which will say on line 15, you have an error, no callable begin functions found for type int star for the pointer. So keep in mind, if we have a function like this, where we are having a array and we have a pointer coming into this function, we can use this to navigate through that array depending on the address that is sent. How about functions and pointers? Just like we have learned in the past, we can supply as a value parameter or as a reference parameter. Same applies for pointer as well. So here we have a pointer where we are sending the address, and we have a double where we are sending the value of that array, pointer, by using the star q, excuse me. So in this function, pointer parameter, both p and q are pointers. The parameter p is a reference parameter because we are sending the address. The parameter q is a value parameter because we are getting the value and sending it. Further, the function pointer parameter can change the value of the q, but not the value, the value of star q, but not the value of q. However, the function pointer parameter can change the value of both p and star p because we are sending it as a reference parameter. Pointers and function return values in C++, the return type of a function can also be a pointer. For example, the return type of the function can be an integer pointer, uh, by virtue of that, we will return integer pointer. Dynamic two-dimensional arrays, we can do two-dimensional, multi-dimensional arrays. So if we have an array of four pointers, we can um, we have an array of four pointers, and each of those array element can be an array in itself. So basically, technically, we will have an array of arrays, which is nothing but two-dimensional arrays. It's a slightly complex, but here is what I just mentioned. We have an array which is board, and each element array of pointers, excuse me, by the name board, and each row in that board can also be a pointer to another array. So this is technically we will get a two-dimensional array. So in reality, board is not a true two-dimensional arrays, because we still are saying it is six elements and 10 elements. So what we are trying to do here is we are trying to do a total dynamic. But here in the previous page, we said this is four elements, and then we have six elements. So we are still kind of, hard coding. If we want 10 positions, we will do six and change it to 10. But if you really, really want a dynamic arrays, we need to ask the user for that, and then apply the logic. So if you have, a statement like this will declare a pointer to another pointer. So this will be a board, and star boards are pointer. Now board can store the address of a pointer or an array of pointers of type int, and the star board can store the address of an int memory space or an array of int values. This is slightly complex. You have to really read through it in order to grasp this concept. It is not difficult. It just sometimes you may wonder the practical aspect of this, but this is not to say to be discarded. This is very important. Here is an example of two-dimensional arrays, and as I mentioned, we are not hard coding. We are asking the user for the rows and columns and creating in two-dimensional arrays by utilizing the values entered by the user, and then we are filling it with some values and then displaying that. So a pretty simple example. You can see how it is done. It shall not take a long time for you to comprehend what's going on here. Shallow versus deep copy. Shallow is basically where we have two pointers pointing to the same uh, value, and deep copy is basically where we have two pointers, referring entirely two different values. It could be same, it could be different. So we have first and second. So if the first is an array of 10, a pointer to an array of 10, we'll have 10 positions. We can fill them up. If we say second equal to first, both are pointing to the same, and that is what we call shallow copy. If we set the second to blank, if we delete the second, the first is also gone. So that is the shallow copy consequence that can happen. So because first and second point to the same array, after we write the statement delete the array second, executes, the first become invalid. And more formally, in a shallow copy, two or more pointers of the same type point to the same address, as I mentioned. If we have something like this, where we are storing the values, we create a second array of 10 positions for the second pointer, and then populate it from the first position. So here we have a deep copy where we are copying the values from one memory address of a pointer to another memory address for the other pointer. This is called deep copy. So it's kind of not really deep, but it's more separate copies. Okay. Classes and pointers and some peculiarities. So we learn about classes. So we can have a pointer as a member variable as well. So here we have a simple class where we have x length of p and a star p, where we have a star p, which is a pointer inside a class. So if we have an object one, it will have a p address, and object two will have a totally different. When we have a pointer, we need to worry about deconstructors, because when we a deconstructor is something we haven't written in the past, but when you have a pointer as a member variable or a member of a class, you need to write the definition for your deconstructor so as to deallocate the memory. Otherwise, you will have a memory leak and you will have a dangling uh, pointer. So if you have a deconstructor, which is the tilde sign and a class name with no return type, you have to write delete the pointer, so that, or delete, whether it is an array or a simple pointer, you have to delete it so that you don't have a memory leak going on. Assignment operator, let's talk about this. So if we have two classes and we fill out the pointer of one of the objects for that, if we have two objects, not two classes, excuse me, and if we fill it out and if we do object 2 equal to object 1, the P will point to the same, and that we got what we have learned in the past, shallow copy, because both of the pointers are pointing to the same memory address, which happens to be an array in this example here. So what's the lesson to be learned here? When we are using the assignment operator between two objects of a class, and if that class has a member variable, which is a pointer, we will result into shallow copy. So keep that in mind. Uh, Similarly, if we were to set the address in the P to something else, then basically we will have a memory leak, because we will lose the address of in both the places. Okay? We do have ability to extend this assignment operator, but that is covered in chapter 13, which is the next chapter. What it would do, both of them will point to, we will have a deep copy, so that if we reset the address, or if we call the deconstructor on object 2, we will not have a problem on object 1, and vice versa. The copy constructor, we can use copy constructor, which is a way to prevent the problem of a shallow copy, where we can have the pointer member variable type object 3, object 1. So if we do that, it will cause something like this, but um, if we extend the copy constructor, we can overcome this problem. If we just use it as it is, then we will have the same shallow copy problem. But by extending, that means by writing our own code, we can prevent this problem. Okay. So let's see this function, which is called destroy list. We have a pointer member variable type, and we are sending an object. So if we have destroy list object 1, the destroy list object 1 will destroy this object, but this will still remain the same. If a class has a pointer member variable, during object declaration, the initialization of one object using the value of another object will lead to a shallow copy, as we have learned. If, as a parameter, an object is passed by value and the default member-wise copying of the data is allowed, it will lead to a shallow copy as well, which is what we have learned. The copy constructor automatically executes in three scenarios, in three situations: when an object is declared and initialized, as we have done. You create a class called a student, and you create an instance of a student called a student. Then default, the copy constructor will be executed. When, as a parameter, an object is passed by value, then a copy constructor is executed, and when the return value of a function is an object, the copy constructor is executed. So these are the three circumstances when a copy constructor is executed. The general syntax of writing a copy constructor is the class name, const, a class with an ampersand, and other objects. So this is what I was talking to you about, whereby you can extend the copy constructor and prevent the shallow copy problem that we have talked about in the past. So we have a simple class where we have a pointer as a private member variable, and we can, this is just printing, inserting, this is the copy constructor, which is what we are learning, and the last in the bottom is uh, the last in the bottom, this is your deconstructor. I'm trying to highlight here, this is the normal constructor, and we have copy constructor, where we are saying that in this class we will have a function which will be the name of the class, but it will take a parameter which will be another instance of the same class. But rather than resulting into copy constructor, we will take the values and store it individually. So here we have a for loop where we are taking the values from one dynamic array and putting into the other dynamic array that we learned in the past. Here is another example of the same type, which allows you to learn about the copy constructor and its significance. Kindly go through this so that you learn what is happening here. Inheritance, pointers, and virtual functions. So um, In C++, it allows the user to pass an object of a derived class to a formal parameter of the base class. This is not only in C++ and in Java as well. You can do that. There are some consequences to that. There are some real benefit to that as well. So let's say we have a pet type, any pet, and it has some public member variable, public members, and some private. And we have a dog type, which is a subclass. It derives from pet. For a pet, we only store one attribute, which is the name. For a dog type, we also store the breed. So we have a print function as well as a private member variable. In the pet type, we're just displaying the name. In the pet constructor, we just set the name. For the dog type print, we display the information from the pet type, which is the name as well as the breed. And if we do call print, which is taking a pet type as an incoming variable, uh, and we can do p dot print. So the significance here that you're trying to learn is what will happen if we are the significance of inheritance, where the dog type is a subclass. So if we do pet type, pet Lucky, we'll have a pet by the name Lucky, and if we'll have a dog by the name Tommy, German Shepherd. If we do pet dot print, we will see pet Lucky will print. If we do dog dot print, we will see both Tommy and the breed will print, because this is what's going to happen. We are calling the print on the dog type, and this will print the first two lines. Now let's learn about calling the function. So if you do call print, and what does the call print takes? The call print takes a pet type. It takes a pet type, and it's a function which takes the base class. So if we call print on our pet and dog, what will happen? If we call it on the pet, we will display Lucky. If we call it on the dog, we'll still display Tommy rather than Tommy and breed equal to German Shepherd. But why? Because the type, which is defined in the function definition, actually makes it such that even though we are passing a subclass, the base class print will run and it will only display Tommy. So this is called compile time binding or static binding. We can do virtual functions and do runtime binding or late binding. It's also called dynamic binding. How do we create a virtual function? We just write the word virtual, so that if we have a function called virtual void print in the pet type, we can have a different definition which will allow us to call on the runtime. So if we do that, then it will display both the information for our dog Tommy along with the breed. So keep in mind the significance of the keyword virtual function when you're talking about classes, base class, subclasses, and so forth. Here is the example where we are using the call print and the main, where we have two pointer variables for pet type and dog type. We define that. We call the print on Q and R, and because the function is a virtual function, uh, because we have created a virtual function for print, it will display the correct information depending on the specific class for which the object is sent. So here, when we are calling the Q, which is a pet type, it will display the Lucky, and when we are calling the R, it is an instance of dog type. It will display both Tommy and German Shepherd, even though the call print is executed. So this is the significance of the virtual functions. When we are supplying as a value parameter for p, we can do p dot print, and if we have dog type as dog, and if we call the call print with the dog, we will display the correct information. So here is how you have the total code for this written here, just so you can understand how it is working. But kindly understand that when we are talking about the value parameter, then we will have consequences, because it will not display the right information when we are sending it uh, as a value parameter rather than as a reference parameter. So keep that in mind. Here is some more explanation for that. So please go through it. Classes and virtual deconstructors. Uh, how do we prevent this problem when we are setting a subclass to an instance of a parent class? Because a dog has both name and breed, but a pet only has name. So what will happen to the memory where the breed is captured? We will have a dangling problem. So how do we prevent that? By using virtual deconstructors. We can call by making the deconstructor of the base class as virtual, we can prevent this problem from memory leak. Abstract class and pure virtual functions, when we don't have to create an instance of a class at all, it just serves the purpose of pure, uh, just as serve for a base class, and it will never be used. We can create a class as abstract class and use pure virtual functions. If we have a class like this where we have virtual void draw and virtual void move, we are basically talking about a abstract class. That means we will never have an instance of this class ever. The only way we can utilize this is by creating subclasses. And as I mentioned, you can use virtual void draw equal to 0 or virtual void move as 0. So these will create pure virtual functions, and what we will get is a abstract class. And here is the entire example of an abstract class having pure virtual functions as mentioned here. You can create subclasses by utilizing as rectangle by utilizing the abstract class, and then you can give definitions to these pure virtual functions. Here is the same concept being explained in terms of an employee type, which is derived from a person type we have learned in the prior chapters. And then we have a full-time employee and a part-time employee. So depending on full-time and part-time, you might calculate the salaries differently, and you might have a class which is virtual, which has pure virtual functions, and it doesn't have any definition for the print as well as calculate pay. Excuse me. And we are going to give the definition for these in the subclasses. So we will have, there is definition for set ID, get ID, and the constructors. But regarding those virtual functions, we'll have a full-time employee as a subclass where we will give the definition of those pure virtual functions specifically for that printing and the salary information. So here is the virtual functions where we are capturing the information. Now again, understand that this concept is nothing to do with the pointers that we have learned. It's just talking about another concept that is mentioned in this chapter, and which happens to be the classes, virtual functions, and abstract classes that you see here. So again, I'm just going to skim through this briefly so you can probably go through it later, and as I've covered the basic importance of this concept. Address of operator and classes. So if we have int x, and if we say ampersand y equal to x, the first statement is basically going to declare integer, and the second statement will declare y as an alias of x. That is, both x and y will refer to the same memory location, and thus y is like a constant pointer variable. It will always be pointing to the same place. So if we x equal to 25, y equal to 25, and if we do x equal to 2 times x plus 30, then it'll update the value of x as well as update the value of y. Okay, so they are basically interdependent, so to speak. Here we have an example of uh, a function that returns the address of x. Usually we do not do that, but if we return an address of x, what we are trying to do here is we have a function, a class where we have a private member variable x, and we have a public function which can give us the address of that x. So basically what we are trying to do is you can get hold of the position of x by utilizing address of x, which is not a good thing in coding, because if you are giving the address of x, you are returning the x, which is a pointer. You are basically allowing somebody else to manipulate your data. So that is something that we usually don't do. Okay, if we do really want that to happen, then what we should do is we'll return as a constant. So somebody cannot mess with it. You can get it, but you cannot mess with that. So read through these two pages there at the very end of this chapter. This leads us to the end of this chapter. There are multiple review points, total of 41. Kindly go through it so that it will benefit you with doing the chapter 12 quiz. The chapter 12 assignment is the exercise 1 listed on page 883. So if we were to go to the page 883 of the textbook, we will see that the exercise 1 is, let's the page 883 asks you to redo the exercise 5 of chapter number 8 using dynamic arrays. So exercise 5 of chapter 8 is about array, but it's about a simple array. So if we were to go through that, here write a program that prompts the user to input a string and output the string in uppercase. Use a character array to store the string. Okay, so this is basic simple static array, but how do we do that using a dynamic array? Here we have an example for this chapter 8 code, which is using a static array. So we have an array of 81 characters. The last one is the end of line character. So we are just saying it is 80 characters array. We are asking a user to enter a string, and then what we are doing static cast to uppercase the values and then displaying as characters by using static cast. So this is using a static array, and here we are using the pointers for the chapter 12 to use a dynamic array. As you have learned in the lecture that I gave you, we are asking the user to enter the size of the string of however long he or she wants, rather than saying it's only going to be 80 characters. And then we declare a new dynamic variable, right? We are not giving it a name, but into this string pointer, which is what a string pointer of a type character. And then we are asking the user to enter a string of the maximum size that he or she entered, grab the values, store it into our uh, pointer, which is the pointing to an array of characters, and then utilize the for loop to simply just loop through that uh, pointer by utilizing the uh, counter. We will read through all the characters, change them to upper, and display. So this is what you need to do for chapter 12. I'll be posting the link to my videos under week 12 and week 13. This is the last week where we are covering the chapter 12. After that, you have a review week and final exam. So thank you for being part of this class. Hopefully this video got some ideas going in your mind about pointers, virtual classes, abstract classes, dynamic variables, because these are very important points. Attempt to do more exercise, and if you come across any problems, let me know. I'll be here to help you. I can sit with you as well as I've done with some of the students, so that I can explain these points face to face setting. I'll be posting these videos shortly. Thank you so much, and look forward to seeing you on the final exam. Bye bye.